So I would like to make another screencast regarding the reading. A few things is on page 600. The Drude model discusses the idea of drift velocity of electrons. It talks about the electrons as going through a series of collisions and then movements and collisions and movements. And one thing based on this equation we can look at is here this equation. They talk about, so momentum is equal to mass times the change in velocity, or change in momentum is equal to mass times change in velocity. I'm sorry. Well, that's true. But then I was thinking about the change in momentum is caused by force acting over a certain amount of time, which this shows here. And they talk about the change in time as the time between collisions for electrons, which I guess to change an object's momentum in classical mechanics, the change in momentum is caused by a force acting on an object for a certain amount of time. And so that the time of the collision is what's used for that sort of analysis. And so, but in electrical theory, it seems that they suggest that the change in time is referring to the time between the collisions, and not the length of time that the collisions take place. So I'm a bit confused on that particular issue. And then also, I wanted to just kind of discuss how on page 601, okay, here we go. This is it. 601, they go ahead and talk about the mobility of the electrons, and how, I guess I'm thinking about this here, where you're looking at, that's not it either. The idea, I'll just talk about it. The idea of a polarized insulator versus a polarized conductor. And the idea that if you have a polarized conductor, you can still have, for example, within a metal, even though it's polarized, that doesn't necessarily mean that the internal atoms are polarized in a metal. Just that the entire material as a whole acts as one dipole, with negative charges on the outside surface on one end of the metal, and then positive charges, I guess, on the outside of the other end of a metal. And so just the outside edges become polarized, whereas all the atoms inside still have their full complement of electrons to make them overall neutral internally. So there's no net electric field internally, yet there is a net electric field for the material as a whole, which is quite interesting. And then one more thing on page 602 it was, which I'm kind of lost here in terms of where I am on my pages. Well, anyway, they were talking about the idea that the world would be quite different if it was not an inverse square relationship between, say, electric force and the distance between charged objects. And I'm wondering why, I guess, what would change. I know the net electric, or the electric fields would change and the electric forces between charges would change. But in terms of would that affect the overall net charge or net electric field for objects? I'm not sure about that, but anyway, that's something interesting to think about.